Yeah. Now, so once again, for the recording purpose, I repeat. So there is a feature called running a process in the background in the Linux. Now, before that, look into this particular command. So sleep 10, after 10 seconds, then echo, print, or echo is nothing but to print something, done. So after 10 seconds, you're going to get a message from the computer called done. Immediately after that, you will get a command prompt. Now here, for the 10 seconds duration, because of this value, you are not able to do any other job. If you give very big value, like 100, etc., then you have to wait for nearly around 1.5 minutes. So 100 seconds. So this is not a problem, but in case if you want to overcome this particular feature of waiting for that 10 seconds without any command prompt, what you can do is that you can perform this entire operation in the background process. What you have to do in that is that in the command prompt, you can write any shell script or any task, not only is this sleep command. If you write one command, a series of commands, something like this. Now, instead of pressing enter key, then you can write one ampersand mark or the and mark here. If you do that, if you press enter key, immediately after pressing enter key, you are going to get a command prompt here. That doesn't mean that this program is stopped, but this particular task, whatever we mentioned in the first line, it will operate, it will function in the background. In the background, it will, you are going to get this particular feature or particular operation done. And the moment if you press enter key here, Linux terminal is free to, or it is here you can enter any other command as well. So one process, this particular process, we call it, technically we call it as, it is pushed to the background. Pushed to the background. And here in the front end or in the foreground, Linux terminal will take, is ready to take any other commands from the user. This is one of the useful feature in any Linux PC. Now let us try this particular program in a shell program. We'll see how it works. Say for example, the command, if I try, so actually I am working with this shell window is not from my computer, it is from my Android tablet. So now you can write some command, sleep. Then you can write a semicolon. Then you can say, write another command. Any command you can write just for a experimental purpose. So if I write this command and if I press enter key, machine will be wait for, now look into the cursor blinking. And after 10 seconds, you're going to get a new terminal window. Now operation is done. So now instead of waiting for 10 seconds without doing anything, same command, I will modify it with the ampersand mark. Look into the way in which it works now. Sleep, 10, echo, done. Now you need to write one ampersand symbol. Now look into the way in which this particular output, I am executing sleep 10 and echo in background process. That is indicated by writing ampersand. Now the moment if I press enter key, you are supposed to get one command prompt symbol. See, immediately you will get a command prompt, and there is a message also 26666. Actually, this is the process ID of that previous command. Previous command sleep 10 and echo done is considered as it will create one single process with the process ID 26666. Now, after completing the process, the echo done will be displayed at the terminal window. This is how these programs or the background process program works in a system. So any sequence of commands. Same thing you can do it with say you can do it with any other commands as well. Say for example, in a command window, if you write say for you are writing a program which takes around 5 minutes to work, maybe a C program. Now you know how to compile a C program. Say you write GCC, then you may write the program name. So for example, test.c and -o, you may say the program name bb. Then we are executing this program with ./bb. This is the usual process of executing a program. Then instead of, in case if this program works for, say, for example, really more than 10 minutes, etc., say assume that this program takes so much a long time. Now, generally, the moment you say ./bb, after that, you will not get any other command prompt here. In a way, you are blocked from doing anything else. You will get a command prompt only after the completion of this particular program. So to avoid that, it is better to write ./bb and push the process to the background process with the ampersand. If you do this, immediately after pressing enter key, command prompt will be displayed. And in case if you have some other task to perform, assume this BB takes around 10 minutes, very long program, very unusual time, anyway, for the explanation purpose. So, but immediately after saying executing this program, ./bb and ampersand, press enter key, your terminal is ready to take some other command, something like printing some text file out or any other task also you can perform by pushing a process to the background. Remember, at any time, any number of processes can be there in the background, not the only one. But at any time, only one process can be there in the foreground. At any time, only one process can be there at the foreground, and multiple processes may be there in the background. In fact, always in a Linux machine, there are more than one process which is running continuously. Many of them are in the background process. So to check that process, actually you have a command. Actually, whenever you in the command prompt, you can say process status -axj. If you give this particular command, it will list the entire series of processes running in the computer. Anyway, now what you have to remember is that you can push a process to the background by writing ampersand or the and mark in a program. And next feature we need to remember about, okay, let us continue with our shell programming now. Even you can use this ampersand mark to a script also. You can write a ./script name, then space ampersand. You can push that particular script to work in background. Now let us discuss about another feature of Linux, that's about command line arguments. Okay. When we say command line argument, now let us say that you have a script. You are having a script of add two numbers, and these two numbers, assume that you are going to enter it from the keyboard, not within the shell code. Instead, you want to say first number and second number. So this add sh takes two inputs, 5 and 15 from the keyboard. If you write a script something like this, we call this as a command line arguments. We say this as a command line arguments. If you write a script to add to this now, add this number, you should be in a position to get a result immediately after that. Suppose the expected output should be 20. In this way also you can write a shell program. So a shell program which takes values from the command line, not from the keyboard. Then when I say command line argument, along with the script name, or whenever you execute this script /add sh, then send the arguments from the command line. We call it as a command line argument. Now the point is how to write a program, shell program, which takes command line argument. The script is, listen carefully. As usual, we'll start our script as per the syntax. We write hash and exclamatory mark. Here you may write the shell path. Any shell you can give. Then you can go on writing. Now, when you execute this program, you assume that you want to read the values from 5 and 15 and add it. But where this 5 and 15 will go? Which variable will it will take? Now, remember that whenever you execute a shell script, something like this, there are three important informations for you in the command line. Look into that carefully. One is the name of the program, and another is the first argument, that is 5. Another piece of information is 15. These three will be automatically assigned to some standard shell variables. Remember, whenever you say $0, this $0 is the program name. First argument, or we call it as a first argument. Generally, it is a program name. In this context, it is add.sh. And second piece of information, that is 5, that is automatically assigned to $1. This is the first parameter. $2 is the second parameter. $2 is the second parameter. These will become the variable names. $0, $1, $2. So in the shell script, you can take that value. Whatever you have to do is that you have to compute $1. You have to add it with the $2. Okay. These are the two different variable names. Just add the variables with the different variable names. Say, for example, if I say the second parameter was In case you can do not only adding, you can do anything. You can write, say, for example, a shell command like echo program name is $0, echo second parameter is $1, sorry, $2, echo first parameter is $1. In this way, you can write the program. So remember, always very important point, $0 is the first argument or generally the program name or a shell script name, or we can the program name. $1 is the first argument. Can use it as a $1 can be together considered as a variable name. $2 is the second variable or second argument. And we know that any variable, if you assign any number, it is treated as a text variable. In case if you want to add, subtract, multiply, etc., you need to perform arithmetic evaluation. Now I will give you a question to you. Try to solve it. Say, for example, on yourself, if you face any problem, tell me. Later in the next class, we can further discuss it. So write a shell script which takes two numbers from command line and computes sum and difference. And displays the result. So take two numbers from the command line and process it numerically. You find the sum and you subtract that two numbers also and display the result. How you can write a program? Think about it. Similarly, there is a special. Now here, what we discussed is about these particular variables: $0, $1, $2. These are the special variables in a way. So similarly, there is one more information, one more variable that is called a $. This $* will give you complete parameter list. Try to echo this also and find out what it is in the previous example. $$, $0, $1, $2. $0 is the program name, $1 is the first argument, $2 is the second argument, $* is the list of parameters. Okay. So this is about command line arguments. Like this, instead of taking the values with the read command, you can always write a shell script which takes result or values from the command line as well.
So I had a doubt.
Yeah, tell me.
Whenever we assign a variable in shell, not while writing the script in the terminal, maybe a variable name a is equal to 5. 5 is taken as a string instead of being a number. So what to do about that?
Yeah, exactly. Then how to compute it? So we executed some codes in the previous lab. How to enclose it within a square bracket and process it.
Okay.
Check out how to. So we did that program shell script. You have to join that tits and bits from the previous class as well here. How to do? That's why I gave you homework. Just look into that. Now, as you said, whatever you said is right. It should consider as a text, right?
Yes, sir.
Then if you take two numbers, one is x equal to 5 and y equal to 5, then how you can actually treat it as a number? Just explore it. look into the previous class. Tell me. That's why I gave you this particular small program. I expect all of you to solve this particular program yourself by looking into the previous class discussion. Try to remember. Okay, these are very important things, right? Okay. You should not forget all these things. In the shell program, then we are writing so many different numerical programs as well. We are taking the value from the keyboard and processing it. And then another point is that we know what is arrays, right? Similarly, we can declare one array also. Now, for example, for your question now, say for example, you are assuming a value, say x equal to 1. Now, if you want to numerically evaluate this particular number, or you want to increment this particular value x equal to x plus 1, you want to perform, then how we can do this? There are many different ways of doing this. One of the ways that you can say x, listen carefully, x. Then you can write equal to, there is one character tilde, you have to write that expr expression. Then you have to write $x plus 1, then end that tilde. So this entire expression is enclosed with this particular character. Then you try to print here echo $x. So then you will get the value of x is incremented by 1. So in this way, you can also write, say, for example, x is equal, here now x equal to 2. In case if you want to do that with some other mathematical, you can write expr. You can write, say, 2 plus 3 also. Or you can, and you can assign this particular value to the x. Now value of x2 and 3 is considered as a numbers instead of text. So explore these commands also. Then the next portion, so we know that in a C program, there is a if statements. If some condition, then in C code, we can say do this set of instruction, etc., etc. So here you can, in a condition statement, you can check any conditions. Similarly, in the shell program also supports for text expressions. You can test the expressions. What kind of expressions you can write? Condition, it can be, say, for example, you can check for equality. If I say, if A equal to B in C language, then do this. We know this syntax. So this is the, whereas here in this particular case, we are testing the condition. Test condition. You can write in this way similar, very different test conditions in C languages. So less than, greater than, less than or equal to, greater than, and then again you can club these conditions using and symbol, etc., etc. Similarly, Linux also supports, or the shell also supports for many different text test expressions. What kind of test expressions you can do? Say, for example, this means that not equal. Similarly, this equal stands for equal, and you can also write hyphen EQ for equal. Similarly, you can write hyphen GT for greater than. Remember this, greater than. Similarly, -GE, it is for greater than or equal. Similarly, less than symbol, and in the same line, less than or equal. And this is not logical negation, not condition. Similarly, logical and operation, -A. Logical and operation, -O stands for logical or operations. And these are the different logical and comparative. So we are comparing the logical compare, testing a particular expression, 5 equal to or x equal to y, x not equal to y, x greater than or equal to, etc. conditions, you can write it. Similarly, there are few other text expressions which particularly we use with the files. Whenever test expressions with files. So these are generally used with the files. Say, for example, you can write -r and a file name. So this means that true if file exists and readable. You are testing whether you, say, for example, I may tell you, search a particular file in the directory. You can search with this command, -r and file name. If that particular file is available, it will say it will be true, otherwise it will be false. Similarly, whenever you say with -w and a file name, this is also true if file exists and is writable. You have a permission to write to that particular file. Similarly, you can write -x and file name. This is also true if file exists and executable. That means that the execute bit is set to 1. When I say -w, you are testing its permission bits actually. When you are writing -r and file name, whether you have got a permission to read that particular file, then it will say yes or no. Similarly, you are testing the write bit with the -w command. You are testing X, the execution bit with the -x command for a given file for a given user. Immediately, you can check whether that particular file is a directory or a normal text file with the -d and a file name. You can say true if the file is a directory and -f file name. In this way, there are several different test conditions. -f stands for true if the file is an ordinary file. Similarly, there is one more -t and some field name. True if the file descriptor is associated with a given file, with a terminal or not, etc. Anyway, this is a different test expressions you can normally associate with the if statements. If equal to, if not equal to, if y is not greater than z, etc. commands. So coming back to the control structures, in the last class also we discussed about this, and if condition also control structures. In the control structures, Particularly the first one is the if. How to write an if statement? If statement, generally the syntax is that you have to write if, then you can write some check expressions here, some conditions, or you can put it properly. Then you can write, then you can write another command here. Some command you can write. Remember, at the end of each statement, you have to end it with the fi. This is very important. Do this. Each if statement ends with the fi. So in between, there can be multiple commands as well. Similarly, each statement also supports for else if. So in that case, the general syntax is that if you can write one command here or expression, then you can write multiple commands one after another. Else if, ELIF. Remember this. You have to write ELIF. Then you can write some condition here. Then you can write then write another command or command. So this is the general, the way in which we can use if and else if. Similarly, there is a case similar to switch case commands. You can write the case condition. After if condition, then case condition. So in this case, general syntax is you write case, then you write some string here, string, then write in keyword, then pattern to check pattern, then you write command one, any command, then write 2 semicolons, pattern 1, pattern 2, command 2, then write a semicolon. In this way, you can write multiple options for the case statement. And at the end of the case statement, you have to end it with ESAC, reverse of case. Remember, note it also. Case is a reserved word, in is a reserved word. Then look into the syntax here, enclosed with brackets. And each case statement ends with ESAC, end of the case statement. This is very much equal to switch case statement in a C language. Say, for example, switch some condition, then you're writing case 1, case 2, case 3, case 4, etc. with different commands, and after that you're ending that switch statement. Similar command is also supported, similar structure, programming construct is also supported by Linux. But the syntax is something different. You note down that how to write a case statement is also very important to remember, and you can use this to avoid multiple or the nested if statements in C program while writing shell programs. And next programming construct is while looping, the third programming construct that is also supported. While the general syntax for while is the keyword while, then condition. You have to write some test condition here. Then after that, write a keyword do. You can write multiple commands. Then at the end, you write done. This is the syntax for while statement. So in this case also, note that while is a keyword, do is a keyword, done is a keyword. So here it is a condition less than, greater than, equal to, depending upon your requirement. You can go for testing the condition. Whenever this condition is true, you're going to execute the statements or the commands between do and done statements. This is about while statements. And there are many other variations also. There is another looping condition is available, do loop and while, do while and while do statements. Similarly, there is one more programming construct available with Linux is until statement or until looping. Now its syntax is you write until and some command condition. You write. If this condition is true or something, this command list is true, then you're going to perform one operation or more than one operation between do and done. Here also you can notice that. Now try to remember the difference between while do and do while. Okay, here also the key until is a keyword, then there is a condition statement, then do is a keyword, done is a keyword. In between you can have multiple shell commands. This is about then our for loops. So we discussed this for loop also in the previous class, I think. So anyway, the general syntax is that here also you write for, then you write variable, then you try to use keyword in, then you can provide a list of numbers. Then again, do and done can enclose command, different statements or commands. So in this case also, for is a keyword, in is a keyword, do is a keyword, done is a keyword. We discussed about this for syntax in the previous class also. Just note that commands, how to write about this command. Now these are the basic command programming constructs available which you can use with the while writing shell scripts also. Okay. So remember these programming constructs, systematically learn this. Try to write some simple programs, very simple, like finding out the largest of the three numbers, the largest of four numbers, etc., using the program. Anyway, I am going to stop today's discussion with in this class here. Now at 10:15, we have an assignment scheduled. Answer to that and upload it before 11 o'clock. Okay. Any other doubts? If you want to ask, you can ask now. Anybody? Any doubts? So assignment will start at 10:15. You have 1 more minute. I will hang up. See you in the next class. Goodbye.